Well, I think that's a neat idea.
I saw you were working with small robots. Maybe I need to assemble one of these to try ideas about location and displacement.
Three sensors. You could do triangulation.
You can use two sensors.
You can do two.
But you must know what side of the line you are, because you have two sides, two circles, section. The intersection of two circles always is in 2 points. This side of the line that connect both beacons, and the other side, and you need to know which side you are.
Yeah.
That's why you need three beacons.
Yeah.
But you can use 4 or 5 any beacons. The idea is when you fire the beacon, you send a code and you say beacon number 1 fire, beacon number 2 fire, 3, and you measure each one by separate.
Yeah.
Well, but it's you spend less than 100 milliseconds. You can do that 10 times per second easily. You can have 3, because sometimes the beacon is not easy to. You can put a beacon in a tree or in the house. You can use beacons with batteries, because you can save a lot of energy if you only are receiving RF. You spend energy when you fire the ultrasonic transducer. But if there is no request, you are not consuming energy.
I like it. I think that's a good way to. You know, we were a while ago. Of course, Jim's got most of it worked out now, but we were talking about ways of tracking our trash can transport and making sure that it was actually where that would have been perfect.
You can use a couple of beacons in a wall, and after you always be in one side of the wall. Okay, the driveway or anything. No, you always at this side. You don't need a third beacon to know where you are, because you will never be inside the house.
Right.
But I am planning to do it with small beacons in a table. Use the robot to drive virtually a path with the robot. He will know the path, and then just follow a virtual line with the robot to demonstrate the use of the beacons.
Yeah.
I like it. I like the. It
was yesterday, okay?
It's so simple, it just went shroom.
I have 100 ideas about different stuff.
Where do you guys stand on your trash can project?
Jim's actually he's got a lot of it complete. He's working on the turning now. He had a small solenoid. He didn't call it a small linear action actuator. It goes straight, but you might need it to turn just slightly. So he was just going to have it bump the wheels a little bit.
A solenoid to change the direction.
Mm-hmm.
And why don't use the differential movement of the main wheels?
He's got it built on a wagon.
Or already stuff. Okay.
So the wagon's got a swing arm, and he was just going to tap. He was going to take the handle off the wagon, and tap onto
to use the wagon. Okay.
And so he needed to get some springs. I didn't quite follow 100%, but I guess the little tiny linear actuator that he's got has 175 foot-pounds, and it could shear the thing off. So he was going to get some springs to try to cushion it.
Can use a motor gear with a pulley
That's what
another pulley this side, and a string with two springs.
I thought
you move in one direction, and another just with the motor.
I had thought that a pulley system would work, but Jim went a different direction.
Okay, but it's okay. They is experimenting with everything. And I always think that each one of us think in terms of your knowing. You ask a carpenter how to close this area. Maybe he think about put some panels, wood panels. Okay, you ask a painter, he will say no, we can't put paint. Or you ask another person. Each one see things in terms of their knowledge. It's okay.
That's part of the reason why I like coming here, because everybody knows something different, and then you get this idea. You can go,
okay.
I didn't think of that.
I used to question all the time everything. I have ideas about everything.
Yeah.
I spent 35 years designing products, dealing with molding, plastic moldings, 3D design, software, everything, all kind of materials, all kind of stuff. And then when I see a problem, I mix everything in my mind to solve it.
I'll tell you what I know today that I didn't know last year at the Star Wars thing. I'm leaps and bounds what I knew. I have figured out so much more stuff, and it's some of it's trial and error, and some of it's you just learn how to do better stuff. So, and then you get an idea like ultrasonics.
I think that it will be better using sound, not ultrasound, just a pulse. Imagine 16,000 hertz.
Yeah.
You won't hear it. The burst is absolutely narrow, but you can use audio amplifiers.
Yeah.
And outdoor speakers.
You're talking about sonar is what you're talking about.
Huh?
Sonar.
Yeah, but without using ultrasound transducer, just an electret micro omnidirectional. You don't need to check all around. Just a micro.
Yeah.
Vertical up or down, and it will receive sound all around.
Yeah. Oh, it's a kid. I'm like, what the heck is that?
A new member.
Yeah.
Now I am planning to learn how to do Android applications. Because I need to use the phone to program devices. I'm planning to learn something about this.
Well,
I started programming using Turbo C many years ago. No, my first experience programming was in Fortran.
Oh.
Fortran, and using
That's not bad.
cars,
That's what people say.
punched cars at the college. Your homework is to design a program, for example, and you have access to the punch the machines to punch the cars. Each car has a line of the code, and you do one line, another line, and you have all your program like the size. You use a marker to draw a diagonal line to see if you mix the car. You always can recreate the sequence looking at the line, Then after you have a program, you have to take the program to a desk And the next year you will have the printed solution of your, okay, you spend always a day to try to run the real program. You have a comma or a dot out of place, the program doesn't work. That's what I learned to program many years ago. Now you do something, compile error instantly.
That's it. That's what Jeremy does all day long.
What?
Programming,
Compile, error,
compile.
fix, compile, error.
Not daily now. I mostly, for my day job, I use interpreted languages right now, but we do.
Sometimes if I'm making a big change in a program, I can stop until I finish because
There's Frank.
right.
Well, actually, I got one project that needs to be help.
Do you have a USB, A to B cable by any chance with you?
A to B, you mean, okay. Let me look.
Arduino
I know what you're talking
style cable? That's,
I got lots of them, but
I forgot to grab mine. I threw everything in the box and
Except
except the cable. It's very hard to do a demonstration.
no, but it's not.
Nope,
It's the A.
wrong one.
oh, okay,
That
that
looked like a little house.
yeah, okay. Arduino cable.
Our Arduino cable. It's very hard to do a demonstration without that
I
cable.
got
No, Ethernet.
Ethernet.
There's
Oh,
one.
yeah, that one.
I knew somebody would have one. All right.
My big problem is to understand in English, and to speak in English. I used to read all the time, but I never speak.
You're fine.
Yeah.
Originally from Spain,
Spain.
and lately the last
My
45 years from Venezuela.
my son was in Madrid yesterday, and he just went to Amsterdam.
Okay.
Actually, both of them were in Spain and Portugal, last couple of weeks. So what part of Madrid?
I am from Spain, from Galicia, northwest,
Okay.
to the north of Portugal, in the corner of the
Okay.
peninsula. But I have family everywhere else.
Okay.
In Madrid, in Barcelona, in
I've been-
Argentina.
Been to Barcelona. My sons like South America. They've been to Argentina too. They've been to Peru. They've been. One of them like to
Well.
hike the mountains.
I love to climb mountains. I used to climb almost all the mountains of Venezuela, Peru, Ecuador, in Africa, the Kilimanjaro. I used to do rock climbing also, but not lately. Diving,
I don't get
hang
it.
gliding. I did hang gliding,
Yeah.
diving, climbing, caving, all kind of stuff. Because Venezuela is
Fun stuff.
very jungle, the mountains, everything is there.
You probably enjoy like the West Coast out in Portland. One of my sons lives in Portland and in Seattle. They do that kind of thing. My wife's mother used to tell them, you don't have to do all that crap just because those other people do it.
That is nice. It's the people with you grow, and all do the same thing
Yeah.
and enjoy doing it.
Friends.
You ready for this?
I'm ready. I want to talk some more about the real-time thing too. So
Okay.
second act. But go ahead. So you got the hat that's on the
No, because we moved recently.
Yeah.
It's in storage somewhere, and it's in a box. And I have this strange sneaking feeling it is at the very back of the storage unit that I can't get to. But yeah, I can't find it.
So you use Raspberry Pi?
I got a Raspberry Pi, but I didn't do anything with it because
you had to get you have this hat thing that goes on top of it. The interface. You got one of those?
I'm 99% sure that I've got one, but it's not where I can get to it.
Well,
It's a Raspberry.
Well, there's an Arduino.
No, I know, but you are talking about the P face or P, something that goes over the.
Yes.
I have one, I think.
oh,
He might be able to.
But I didn't use it too much. My son loved to use the Raspberry for everything.
Yeah.
He's in England, working. He's making a doctorate in mathematics, so he loves programming, and he loves to use the Raspberry. Every year he gives me a new one. You know.
Yeah.
Lately, a month ago, he sent me a Raspberry with the case and all the stuff that can a kit
Yeah, can a kit.
all the kit. Well, it's already with the tape. It's closed. I didn't open it.
didn't open it.
It's waiting for.
I got mine going. I got Cody on it. I still haven't downloaded. What's the thing? There's one main streaming app.
I don't know.
He knows because he had it loaded on his when he had it in here. I can't think of the name of it. I just wanted to make it work.
Yeah,
It works.
it works. Well, I didn't because it's buried somewhere in the storage unit, and when I get in there and I can dig it out, I will, unless somebody has one. Mine's not exactly a pie face, but it's the same thing. It's the same idea. It's the same.
Let me check. I have confusion because I have almost the same stuff here and in Venezuela.
Yeah.
I have also a Raspberry there, but I think that the P face is here. In the case of the Raspberry B Plus or something, a former model.
Raspberry 2 B Plus or
Yeah.
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 3.
Well,
Because that's a little bit better. Raspberry 3 is a little bit better. Than
Yeah, it includes the Wi-Fi interface and plugging.
but just to see a demo of how the pie face works, it doesn't really matter which one it's on, because they're all pretty much the same at that point.
If I think about it, I don't have a pie face. I'll order one. It takes a long time to those. Can you get those things locally, or that's only China?
They're expensive locally.
Okay, it's China.
It's China. So what I actually ended up doing, because I don't even remember the guy's name, the guy that did with the Raspberry Pi and the Koniki kit.
Yeah.
He was trying to do a speed.
Oh yeah, with the bullet.
With a bullet.
Yeah.
Well, Jim had emailed me his thoughts on doing it with a digital input instead of an analog input. And when I went back and I read all the stuff about it, everybody's doing it with analog. Everybody's doing it with analog. So I said, why not do it with digital? So I tried it.
And?
Maybe. It works, but I'm not so sure how good it's actually working. Because I don't really know. The math is right. If everybody else's math is right, then the math is right. But sometimes I get speeds of like 3 miles an hour when I know that it's been sitting for way longer than 3 miles an hour. So, I also decided to use just an infrared line tracer.
Oh, okay. You got that thing.
It's not the one. It's a different one.
Okay. It's not the same.
It's not the same one,
Yeah.
but it's similar. They're all pretty much similar. But I hooked it to the digital inputs instead of the analog. So you get See, like that said that was 3.4 miles per hour. That was -8 miles an hour.
I think there may be some problems.
Everything that I've read about this, so they take an average. You have to shoot whatever you're shooting 10 or 15 times and get an average of whatever the outcome is. So
What are you trying to measure?
Muzzle velocity or not?
The velocity of what?
Speed, bullet.
Speed of what?
anything,
A bullet? No.
bullet,
300 meters by second, for
yeah,
example.
it-
Okay, you need hardware for that.
yeah.
Comparators or high-speed comparators.
That's what I was thinking last time.
Yeah, I don't think any of
Or
this.
use a very separate sensor. You know?
Yeah,
You want to do it with very close sensors. You need a very how do you say the slopes
yeah,
need to be very fast. You know, no
Oh, you mean the rise time?
rise time. Yeah.
but I think that's why they're doing analogs on them, so they could get an average off the analog too. I don't know. I took this idea from, they were doing this for Matchbox cars. They were rolling Matchbox cars across the track. And they had their sensors above it, looking down.
Adafruit is selling the transmitter and sensors.
Yeah.
The cables I separate. You know.
Yeah.
But I was working with laser.
Yeah.
A laser and a mirror
Yep.
and a glass and two sensors. And the first glass split the mirror 50% of the laser.
Yep.
And the second is the mirror that is the rest of the laser light, and two sensors here.
Yeah.
And use the matchbox cars to find the speed of them, you know. But this is absolutely fast.
A laser would.
A laser with a opto sensor. It's a phototransistor.
Well, that's what they're all using too, is photoresistors, and none of them are using the infrared.
The LDR are slow for this.
Yeah, he wanted to use IR. I just thought all the other projects I've seen are all using photoresistors and some regular light, and I don't know if IR is really the right thing to use for this or not.
Laser costs $1. You can use
I guess it
two
depends on what
lasers.
the environment is giving off. Whatever the environment's not giving off would probably be better.
Yeah, it seems like it works, but it's not. I wouldn't trust it for any particular reason. But it led me to another idea, which if you give me a second, which does actually work and actually works pretty well. I actually was quite surprised with myself. It is not a Mega, it is an Uno. So I was playing around with this and realized, oh, that is not what I want. That's what I want. And realized what I was actually doing was triggering each one of these. You know, that one gets triggered, and then this one gets triggered, and then this one. So if I look at which ones get triggered, I know which direction something's traveling. And infrared, this one, you have to be really close to it to get it to trigger. But the other ones, I think you could be a little bit further away from. So now it says moving left to right, moving right to left, and you know, it works pretty fast. As long as,
Can you move your hand fast enough so that it won't trigger?
I think it's triggering. But I'm pretty much on top of it. I'm pretty much touching it to get it to do it. But it works pretty well. And it's real simple code.
How fast are you scanning it?
It's pretty fast. It's just in a loop.
Oh, it's just in the loop, so
Yeah.
you're really fast. It's not doing anything else.
It's just checking. It sets the milliseconds. Every time one of these triggers, it sets the millisecond. And then it checks if this millisecond's smaller than this millisecond, then it must be going that direction. If this millisecond's bigger than this millisecond, then it must be going this direction. That's a real simple idea. And it was one of those, when I was sitting there playing around with the speed thing, I went, this is a real simple gesture sensor, and if I had two more, I could go up and down, doing the exact same thing. So that was my. Don't look at me like that, Frank.
I was waiting for the hat.
I know, and I really wanted to do the hat.
Well, you know, you've been doing the real-time task controller or real-time. I won't say OS because that's bad with Arduino.
Yeah.
And I've been pushing you to expand. So
Right.
I didn't write it in code. I've been writing down my thoughts though, so I can explain what I'm going to do.
Real time for Arduino. Real time operating
Yeah.
system.
Yeah, it's probably not ready. It's not ready for a real OS. But if you have something
It's a
slimmed down,
thread scheduler or
Yeah.
something like that.
yeah, right, like that. Actually, that would be a good name. Okay, you have your. I got my adapter, so I can plug into the.
Today I am starting a course from Texas University about real-time operating systems using the ARM microcontrollers.
Okay.
It's free and it's at your own page. The course, I have already all the parts. You need a ARM microcontroller from Texas. You need the environment that they use, that is Kale hide, and everything is working okay. I did a lot of stuff practicing, but now today begins the course about real-time operating systems. They are planning to make a game or something with a lot of sensors and buttons and to practice all this kind of threads and time division and messages between threads, semaphores. I did it many years ago, but I want to refresh everything, just following the course will be interesting.
A really long time ago, over the 8080, I had this microprocessor test set. This is when they had processors that were just really big computers, and they didn't have software to trap stuff inside it. So what you do is you put these comparators on the bus, and then you connect a microprocessor that has a matcher, and so you set up the matcher with the microprocessor, and then when it triggers, you capture stuff and store it, and then display it on a LED. But it was done with 8080, so it seems that 8080 is
slow motion.
compared to like even an Arduino. But I forgot how. Basically, I had it working like a real-time clock. I had, and I don't know how many milliseconds was the basic time, because one of the things I did was actually just update a clock, counting seconds. But had things that were done every 100 milliseconds, things that were done. I remember debalancing buttons that was like 60. It had a keyboard, and you had to scan the keyboard, and debalanced it. That was 60 milliseconds, I remember. But got everything done. And I worked on switching systems, which were like 68,000 microprocessors. Those things did everything. They handled, there was a line unit would have like 4,000 subscribers. It handled everything.
My first program was in assembler in a PDP 11.
Okay. Wow.
With switches, was a practice.
Yeah.
Binary code was octal code. Every three switches, one code.
You have the switches, you program.
Yeah, loading,
Yeah.
moving,
Yeah.
loading.
We use that to boot the thing.
Yeah.
Because after you get it booted, you can load a tape.
Like
Those were the days.
64 switches to throw, just to make this boot load.
64 would be nice. I think the fire control computer. No, it might have been sonar. It might have been sonar on the boat that I was on. There was probably 3,000 switches that we had to throw before we could boot that thing up. And they had to be in the right order, and you had to follow the steps.
You have the cable for the.
Oh, that cable.
Yeah, I got my adapter.
You don't want to do Chromecast, huh?
No, this works. Let me think. Do I want to do Chromecast? Actually,
You always use this
I
room.
could do Chromecast.
But
today.
This room is always the same room that
Yeah,
you
Yeah,
use for
it is, but we have to,
There's nothing.
we get in here at
So I don't
5:35 and have to be out by 7.
7.
Yeah.
Yeah.
every week.
Every Thursday.
week, yeah.
Sometimes there's structure, and sometimes it's like this.
I was thinking about to come since I saw you in the Star Wars something,
Yeah.
but I was dealing with a lot of problems in my business and I had no time. Today I was thinking not to come, but my wife said, go, learn, speak in English, go. Okay.
Well, I'm glad you came because you've given us, you have given me some ideas of how to get one of those robots to do.
Which robot?
He's got some RF and ultrasonic, so he's keeping track of position of the robot.
So how many?
Or a dog. It was a puppy that you were keeping track of.
Well, it's a project,
How many sensors?
Since last week we have a new puppy. My wife asking for use a virtual fence, around. But they need to dig all the garden to put a wire or something. And I was thinking yesterday to use some ultrasonic ranger to put in the bed of the dog,
Okay, so it's one sensor?
The bed has a receiver, an ultrasonic sensor,
Okay,
and has a RF sender.
okay.
The sender sends a signal to a beacon, different beacons, and asks the beacon where I am, how distance I am from you.
Okay.
Our signal fire the ultrasonic burst, and you know exactly with 1 centimeter exactly.
So you think about using that for guidance.
Yeah.
It's like you have this bordered area and you can guide based on the beacon.
Or
You know what your relationship is to the beacon, so I want to go right, I want to go left. You know where your target is, and so you can guide.
brilliant.
You can guide the robot that way.
I thought the idea 2 days ago, but I need to implement it. And yesterday night it works. Okay, I put 16 meters distance, and you can have a resolution of 1 centimeter. The sender is the same standard sensors, but one only send and one only receive.
Yeah, but those things don't have great range. So what kind of range are you getting?
The range, because they have a short range, because the energy needs to go and propagate against something and come back. You have a directly line, one sender and one receiver. It's a lot of more energy. There is no obstacles reflecting energy. It's straight rate, of energy.
It's kind of like alignment, line of sight.
Yes, 14 meters is 35 feet.
Okay. So you're not bouncing it off a wall or anything. It's just transmit.
Yes,
receive.
yes.
Okay, so you get better range.
But the idea is to use a wider transmitter with more energy. Okay, you will receive reflections, but always reflections will be will arrive later than the main one, you know, and you only are looking for the fast one, the first one signal. The reflections doesn't matter, and you need to increase the power of the transmitter to increase the voltage, and maybe cut the can then where they are in a small tunnel, a small can.
Yeah.
Cut the can to permit the energy to go in a wider path, you know.
So you're not using 5 volts. You're using what? 12
Well,
volts.
this standard transducer use 24 volts.
Wow.
They has a chip that convert 5 to 12, and then use a H bridge to produce plus 12, minus 12
Minus 12.
in the transmitter. This is standard one, okay? So you can use a bigger power supply and maybe a bigger transducer, or use several, you know, each one cover like 60 degrees. You can use 3 or 4 in a path and fire them simultaneously to produce a path in no directions. Doesn't matter where the target or the dog is, always will receive energy from the
I
beacon.
didn't think those things could support that kind of voltage difference.
Excuse me?
Okay.
They support 60,
Minus
60
12
volts.
plus 12, what is 60 volts?
The ultrasonic transducer,
Yeah.
the specification is maximum 60 volts.
Is that the same one we're using?
Yes, it's the standard one that you buy by $2.
Yeah. I thought those things were
But
like
it has
volts.
the chip that convert 5 volts in plus 12, minus 12.
Okay. I didn't know about that.
Is the transducer piezoelectric? Is that?
Yes, usually. You can use a more powerful, but they are expensive, you know. Maybe you can use several standards. Those cost less than $1. Use and solder them forming a path. Fire them all simultaneously,
Yeah.
and cover a wider area. It's a matter of experimenting. I bought several this morning, maybe in 2 or 3 weeks. I will have them to experiment how is the path, because also you have this dimension, you know, you have the area in this direction, and you need to know how wide is this direction. You can lose a lot of energy if you permit the transducer to work open without the case. The energy will go everywhere and will dissipate very fast.
Do they use a horn to get?
Maybe a horn or a combination, maybe made in a 3D printer, a horn, or I was thinking on to use a commercial speaker and use audio signals, 50,000 hertz or something, and very short burst. It doesn't bother anybody, and you can use standard amplifiers and outdoor speakers. They have a very wide path, and you can send a lot of power with them. You know, you can have a 20 watts amplifier for $15 or something. Audio amplifier that cover from 20 hertz to 20,000 hertz, and you will send just a burst in the range of 50,000, 15,000. And the good thing is that the receiver will be omnidirectional microphone. It will receive, doesn't matter where the sound comes, it will detect the sound. And it's cheaper also. It's very cheap, the electret micro. A lot of experimentation is needed, oscilloscopes, amplifiers, and distance, and boom. But then you have a new product, a system to do anything. I was thinking on to design a robot to cut the grass using this coordinate system, you know. Just program the robot, and he knows all the time where he is.
Where it's at.
In precision.
I had to get rid of my robotic lawnmower.
Why? Cut your dog in two?
No. Well, we moved to where there's no yard.
I was thinking to use a GPS, you know, but the GPS is very hard to resolve more and plus minus 3 meters usually, you know.
Yeah.
It's a lot of distance for a perimeter for a dog, you know. Will be a plus and minus 3 will be 6 meters.
Yeah.
Will be 18 feet. It's a lot of distance.
You can find some GPS units that give better resolution, but the cheaper ones are all about 3 meters.
But the best resolution technically is limited to 1 meter, I think.
Yeah, it's about 1 meter.
You can use some kind of air station.
Yep.
That transmit it's a correcting system for the GPS.
Yep.
But I don't know if this will be expensive. It's used in aviation for the precision GPS for landing. It's a beacon that knows exactly the position and send the correction distance to the GPS. And the GPS knows where he is in a circle of 2 meters diameter, and the air station send in what direction is the error, and it corrects and can define several inches, you know, with precision. It's incredible. It's used now in the automatic landing systems of planes, you know.
Speed of light's about a nanosecond per foot. So as you get shorter than that, you have to have rise times of...
No, I was thinking that I need to correct the delay RF sensing. No, absolutely. This means 2 millimeters or so of error. Nothing. It's incredible. Works. Trust me. It's good.
There's another one. There it is. That's not the one. I've got some.
Jeremy, you don't have application in your laptop.
For what?
I've got some
It's empty. Your
scribbling.
how you say this main screen is almost empty of icons.
What do you
Oh.
That's not me.
That's me.
That's him.
No, that's.
Oh no, that's him.
That's right.
Yeah, this is not good.
But you use
Not good housekeeping.
this
Mine's totally empty.
Chromecast or something?
Yeah.
Well, it's weird.
Mine-
Like my Linux machines, I never
Yeah,
have
yeah,
anything on my
okay.
desktop.
I thought you were connected to the screen. Okay.
It's weird. My Linux machines, I never have anything on my desktop. My Windows machine look like that.
Windows looks like that. Linux, I think I've got 2 icons on my Linux
I
box.
think it's because there's no good place for them in Windows.
And of course, the Chromebook has no icons. No icons is good.
It's like, okay, okay, my documents. It's not really your document. We're just gonna put all sorts of crap here. Okay.
Really,
Oh, directory.
seriously, Frank, how do you get around with that many icons on your desktop?
It's a Windows necessity.
You know where
It's
something is
a
in my position. You know this position, my position where you have every file and every program.
Okay, here's what I do. I just add these things like when I'm
Organize it by
currently
areas.
working on them. I'll tell you what else I do. I'll create another folder and I'll put all of these in the folder and start all over again. The idea is that whatever I'm working on should be all in front of me, and it's a bad habit. As a matter of fact, I'm actually a college instructor, and I teach a lot of beginners how to organize a file system. And I have them set it up by their classes. You know, you have a class, then you have subfolders, and you have subfolders for assignments, and then I do this. So I don't practice what I preach. And I have a lot of computers that are just the same way. At least 3 that are the same way. Okay, I think I didn't save something, but I still can talk through what I wanted to talk about. This one maybe, I'll talk this one and I'll open up the other file. Okay, the idea for a real-time OS, we've been talking about it for a while, is to make better use of the processor that the Arduino is. And the Arduino, compared to really old microprocessors, is very fast. And compared to some of them, it even has good memory. The one we're starting using a wireless chip, ESP8266, which has got wireless built in, just like the Pi, and it's got a pretty good amount of RAM. Has all the I/O that an Arduino has, and it would be good to have that one processor be able to control a robot, look at all the sensors all at the same time, and run efficiently. Now, Leroy, last time, he had a demo that really demonstrated how you can do 5 or 6 things at the same time. And he had a robot that does it with it. I think if you went closer to like a real OS, you can't do a real OS, but if you got closer to that and you actually created objects, independent objects that could communicate with each other, and you only run that object, you don't run them, you don't have large time slices. Let's say 15 or 20 milliseconds would be max that you would run those those classes. I'm rambling a little bit, but one of the problems you run into is sometimes you need things like that sensor, the sensor that you're talking about, and you have to stay on that thing. You know, it's like you go and you interrogate it, and you may have to do some timing in interrogating it. And if you have a lot of operations going, you can't spend all that time in a loop waiting for timers. Leroy got rid of some of that. What was it? Using the library.
It's the robot was actually using 2 separate independent sets of timers. Really, one set of timers was working for the motors, and the other set was working for the ultrasonic.
But everything worked off the millis clock.
Everything worked off the millis clock.
And then every time, like you had, I know at least for those lights, there was a separate object that was instantiated for every light.
Yes,
so
that was
that same object. You pass the different parameters, and it was going to behave differently just based on that object.
And that was done with the timer library, timed action library, not the motor library.
Okay, and that used the millis clock. which is actually, that's very efficient because you do some operation, the object is still in memory, and you can return to it whenever you want to return to it and change it, which is, and in that situation, you're not using timers at all. And as long as you have devices like that, that you can have as an independent object, and you do some processing, and then you do a time slice and do some more processing, and when it finishes, then you get maximum efficiency. And I think if you can do that, then you can do what was done with the microprocessors in the old days. Like, I worked on the 5ESS switching system. And like I said, those line units were controlled by 68,000 microprocessors. It did all kinds of things. When it collected digits, it connected up ringing circuits. It connected paths. It did all kinds of things. And the clock wasn't that fast, but the software was very sophisticated. And it didn't have like a real operating system. It had like it was like a peripheral unit, and it was a peripheral controller. But the thing was very, very complex, but it really worked well. I mean, call processing, we were losing calls. It's not like now,
The one thing that I want, that I've been thinking about with that particular, I have to go and I have to call and check the Millis clock every time I do something. But I was thinking, if the motor library was actually built to check its own internal Millis clock.
What's the same, whether the code is in the library or your code is really something.
Well, I was wondering if it would work as well, because would the library release it back, or would it hold it while it's still checking?
Okay, that depends on the library. I mean, I haven't seen that library, but it depends on that. In that example from Adafruit, you saw that example?
No, I asked you, email me that example, because I haven't seen it yet.
You haven't seen it? Okay, that one was very good. That one gave me the idea. What you need is a class for each type of peripheral, whether it's a sonar or whether it's a light.
Okay.
So you create one of those. And then if you want it, like in the case of those lights, you just instantiate, in that case it was 6 lights.
Right.
And you pass different on/off times to them, and they operated independently.
Okay.
Now the same thing with the sonar. You could operate the sonar. This thing did the lights, operated the sonar, and also had some servos that the Adafruit one, servos that were turning all at the same time, and it worked. Now another thought that I had is like,
email me that.
Okay.
Either the link to the library or the library or whatever.
I don't know if you can see that, but I think for the kind of stuff that we do, you have things like switches, you have temp sensors, line sensors if you wanted to trace the line, you have photo detectors. These are things that are on the little robots that we built. A compass. To piggyback off, my thought with the compass was actually similar to what you're doing with that beacon. Is that if you have a defined, and I don't know how well it will work, this had to be experimental, but you have defined boundaries, and with the compass, where you are, and if you know where your destination points are, like you have a map, you can have your robot move toward that direction. He's thinking. Go ahead, think.
I know the compass gives you bearings, but I don't know if it gives you distance.
No, it doesn't give you distance.
So how are you going to keep track of the distance?
Okay, what you want to do is the difference between the heading that where you are now, and the location where you're going to. What it doesn't do is it doesn't tell you how to navigate, but you can move in a straight line toward that coordinate. That was my thought anyway.
But okay, yeah.
This is
I mean, the bearing would change every
like
time.
What you have with the beacons, you can't use GPS because it's 3 meters or whatever, and kind of these robots we've been thinking about, you need to be within inches.
Well, actually, for the trash can transport, we said it would be good if it would go within a foot of where we want it.
Yeah, but
and Jim's been able to get it down to a few inches
and
every
he's
single
doing
time.
that with the
But
compass,
you,
right?
you will go from one place to another place,
Yeah.
but following a path, a virtual path, like a line in the floor, in the
Yeah, no,
floor.
that's what I was.
This line is
that's
made by different points that you put in the software.
That's
So
what-
here, then here, then here.
That's what I was going to do, but he's not using that because
He's
there are problems with the line.
he's pretty much using a compass.
Yeah.
Um,
He's using the compass for. How does he know where the end point is? How
The
does he know when
compass,
to
he
stop?
knows the direction, right?
Knows the direction.
But the direction will be straight to the final
Right.
point.
in that particular robot, yes, the direction is straight.
How do you stop?
That
Now, see, that's what I was thinking. Is that if
No,
you-
but I mean, you can split the route in different sections.
mhm.
Will be straight from here to here, from here to here, and you follow a path.
Yeah,
There are several segments
if you
straight.
if you stored the path,
if you stored the path.
right?
Yeah.
Yes, because maybe the driveway or something has a shape, then go here, and you design the.
We're going. I know he was using the light at first, but I don't think he's using light
He's not
anymore.
using the light. The compass, I think he got to within an inch. It was really that
It's
close.
within like 3 or 4 inches.
But in
Yeah.
his case, he was just going to go straight. But I don't know if he ever came up with how he was going to stop, because he was thinking of having something there at the spot to say, okay, I'm there.
I'm here.
Yeah.
Yeah.
But if he did store, like you say, the different points along the way,
Waypoints.
yeah, right, then I'm here, and then when you get to the end point, I'm done. I don't know how accurate that would be, but it sounds logical.
Well, I know those compasses that we're using are very, very accurate, but my real question is can you really navigate from that?
His problem is that, those things were sensitive to magnetism. So
Yes.
if you had a car in the driveway,
It was
Yeah,
done.
but you need a lot of sensors and some intelligence to move in the
Yeah.
real
Yeah.
world. There is a kid or a dog or some obstacle new or a newspaper can stop everything. Just a newspaper in the middle. You need to have a lot of sensors.
Yeah.
Maybe a camera and some image processing. So everything is clear, or there is something.
Well, we've gone through the image processing model too. We've tried image processing.
you got to be cheap too. This is a very cheap group.
Everything is becoming cheap. A camera, how much costs? The problem is the software.
Well,
and Arduino is
the camera-
not capable to
Those
process.
cameras are getting cheaper every day. So
I would think a problem with a camera is if one wheel goes down in a hole, the camera is looking at a different place than the direction of
you
that.
build
Okay.
intelligence into it to deal with that.
Well, if you got a wide enough angle.
You need accelerometers. You need compass. You need beacons or.
And so you need
you
a
had-
real-time operating system.
If you had a compass plus an accelerometer, you probably could do some fairly decent navigation off of that.
Okay, we got all this on my list. We just got to make it work together.
There are algorithms, or now there is hardware with accelerometers that can compute the distance where you are. After several hours or something,
Gyroscopes.
it loses the position. But if you know where you are and you correct the position with accelerometer, you can move a lot of time and come back
That's
with another
basic-
position.
That's basically how our inertial navigator worked. It was a gyroscope with accelerometers on it. So,
Okay.
It's a complex algorithm about integration and something, but
yeah,
many manufacturers include the processor with the sensor.
yeah.
And the processor already gives you the coordinates. You
So-
don't need to integrate.
So if you know where you start at, you should be able to navigate
For a long time, yeah.
pretty good and not get so far off.
And after you come back, you will correct the position.
Yeah.
Because you touch something or there's some element that correct your
That's-
position.
We always had to come up and verify that we were at
This is
where we thought we were.
The cleaner solution, I think.
Yeah.
Okay, so,
So-
you need real-time,
Yeah, well, you need to be able to keep track of all that
all these tasks,
fairly
you know,
quickly.
going on at the
Yes.
same time. So, and you want to do it with, one small processor. Leroy built this robot.
Well, he saw.
You saw,
The
Hero?
Hero,
Yeah.
the one.
how many did you have in there?
7
what?
processors.
Okay.
They weren't all technically weren't all for control or anything. I used a processor for the
Audio
lightsaber.
also messages and
Yeah.
audio messages and music and that.
Yeah.
That's
And they-
But there were 7 processors in there all talking back and forth to each other, doing various and
so
sundry
you can
things.
get all of this stuff, make better use of the real time, get it all in one processor.
If you could get if I could get everything that it was doing down to 2 processors, it would make life a whole lot more fun.
So that's the end goal.
If I could get it down to 1 processor, it would make life even more fun.
And it kind of, you already have it going, but what it has to be is more efficient.
Yeah, mine works pretty well. I think it could be better, but it's doing what you said for it to do.
Okay, but it could do more.
But it could do more.
Yeah.
Yeah.
For instance, and it gets hard because like when you're reading, when you're loading characters to the display.
Yeah.
Theoretically, you could load 1 character because it's not a fast thing, and you keep going in cycles, and you load 1 next time. You don't take up all of your real time to load the whole display because you can miss something else. And those fast tasks that you need to do absolutely on time, you can miss some of those.
Usually, before you use a real-time operating system, you can use interruptions for a lot of things.
Interrupts.
Interrupt. Yeah.
For example, to control the movement of the old robot, you only need 2 interruptions from each one of the encoders, and you never take care about movement until one encoder fire an interruption. You go, what happened? Hey, my last interruption was this time ago. Oh, this means this speed, and I asked for the movement with this speed. Okay, continue. Go to do another thing, or wait, you already moved what I ordered. Stop. But the interruption of the encoders control everything. You don't need to take care about the movement of the robot.
Well,
The motor has a signal, a PWM signal, and it's moving, right? This is the order to move. And then you forget about movement until an encoder interrupts you. What happened? Hey, I am passing. Okay, you are okay. The speed is okay. No, you are a little fast. The PWM a little lower, and I return to the main program. It's just a second, nanoseconds.
Okay, so
interruption.
let's say you're doing all this interrupts with the encoders and the PWM. What about the rest of the stuff that you need? Like you need to be scanning the compass and
The problem with interrupts, especially on the Uno, is it stops the millis clock. The interrupt actually will stop the millis clock. So it'll break if you've got any other timing built into it, it'll break the timing. So an interrupt
so
is
you
not
would have to use your clock based on the interrupts. And actually you'd have to have like a synchronous interrupt. You have to have more than one interrupt.
Well, on the Uno, there's only 2 interrupts.
Okay.
So my particular thinking on this is actually doing what I did a long time ago, just with one encoder, one sensor, and knowing where it's at, and then being able to call that routine up and check to see if it's actually where we think it is every single time without calling an interrupt.
I will check that about how to maintain a time base, a very high resolution microseconds or milliseconds.
Millis is what we've been using.
Yeah.
Because you can have an interrupt for microseconds, and every 1,000 interruptions you will have your own counter of milliseconds.
Yeah.
The worst.
See, that's what I'm thinking.
When you take the interrupt of it, it has to be fast. I mean, you can't execute a lot of code.
Yeah.
No,
So you have to make sure that.
come and go. Yeah.
Because if you execute a bunch of code, then it really does mess with.
Unless you are the
timing
main task, you need to control and you need to stay, and everyone else must wait. But this is not usually the case.
Well, my other thought on that is if you're going to go that route, you want a separate processor just for the motor control, so that it can count the clicks and everything without messing up the timing of everything else, but it would still be able to talk to the other.
All right, so we went down that slippery slope, but we just went over. We got another process.
There is a launchpad from Texas Institute.
Yeah.
That runs in energy environment.
Yeah.
And the energy environment can manage multi-thread. And you type different sketches, and all of them are working together in the same processor.
What?
The environment takes care about the.
What?
Oh, this is my computer saying that I'm running out of
Battery
battery.
running low.
Yeah, well, I think I got
Do
one.
you know what model that one is? Because
The name, no, it's MSP. I can send you the information.
yeah.
But in the energy, the last 2 versions of energy has the multitasking environment.
Yeah.
To type a sketch, open a new sketch, and you download all the sketches to the same processor.
Yeah.
And all of them.
So this is the processor.
Yeah, it's one of these.
It's a real-time operating system.
It's one of these launch pads.
Okay.
It's something like that.
I've got, I did a demo with a couple of these low-cost
Yeah.
TI launch pads,
Yeah.
but he's talking about one that's can handle real-time operating,
Okay.
much more efficient. So it might be something to look at. They're easy enough to program too.
Okay.
It's 40 megahertz. The speed.
Cheap too?
Well, this one originally was like under $15, but
Oh, that's
No,
good.
the other one is an ARM
Okay.
processor.
It's not gonna
The board cost $11 or something.
yeah, and this one was on sale, or is on sale at MCM for like $5. So I grabbed one just because.
Okay, so that's my next goal is to do real time with. You can start doing a lot of things if you can have like a reliable real time. And you can use something like a Raspberry Pi, but the Raspberry Pi uses a lot of power, and the I/O action is just it's not Arduino. And you have to deal with that operating system when you want to do I/O.
The first, just put in Google Energia multitasking launchpad.
Okay.
And will appear.
Okay. Well, I was going to give you my email address anyway, just because. Thank you. With my messy paper.
I send you an email.
I didn't get your, I've got here for you. My name is Frank Hill.
Hi, Vicente, like Vincent, but in
Vincent,
Spanish.
Vicente.
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 Vicente. Jeremy. I forgot your name.
Don.
Don. D-O-M?
D-O-N, yeah.
N. D-O-N, Don. My neighbor is Don. And his wife is like Don, but it's a different letter. It's also
D-A-W-N is a woman's name for
like
Dawn.
but they sound the same for me, okay, Don.
Okay, this looks like a connector board or something.
Yeah, it makes that other board a little easier to use. That was like $3 or $4 or something for that connector board.
I think that
Frank,
real
Yeah,
time,
Frank.
when people talk about real time, they're talking about simultaneity that happens in a reasonably short amount of time, but it's
for the
not
task,
zero.
for the job.
No, there's no zero.
Okay. Real time can be very slow if what are you doing is happens in slow. The events are very slow, for example.
But inside of the processor that works at 3 gigahertz or something like that, it has to take all of your registers that you're working with and write them out to some memory. It doesn't have to be, your.
Depends. For example, I used to design 3-phase relays